Linux user account is not just a name you recognize on a login screen, because it is a structured identity that the operating system uses to decide what a person or a service is allowed to do. When you add, modify, or delete accounts, you are changing security boundaries and changing how processes will run, often in ways that affect files, services, and audit trails long after the moment of creation. Beginners sometimes see account management as administrative housekeeping, but Linux treats it as foundational control because ownership, permissions, and access decisions all depend on identity records being correct. The Linux Plus exam cares about this life cycle because it tests whether you understand what changes when an account is created, what needs to be adjusted when a role changes, and what must be handled safely when an account is removed. This lesson focuses on the full life cycle, from creating an account to adjusting group membership and shells to deprovisioning, and it keeps the emphasis on least privilege as the steady rule that should guide every decision. Once you can narrate this life cycle clearly, account questions stop feeling like trivia and start feeling like predictable system behavior. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A useful way to begin is to understand what an account actually consists of from the system's point of view, because that makes the lifecycle steps feel logical instead of arbitrary. At minimum, an account links a username to a user identifier, UID, associates it with a primary group through a group identifier, GID, and defines a home directory location where user-specific configuration and data are expected to live. The account also defines a default shell, which is the program that becomes the user's command environment when they log in interactively, and that shell choice affects both usability and safety. Behind the scenes, Linux stores user and group definitions in a structured way so processes can map names to numeric identities, and the system uses those definitions constantly whenever a file is accessed or a process attempts a privileged action. A beginner misunderstanding is thinking that the username is the identity, when the identity is really the UID and GID values plus the policies that interpret them. This is why account changes can have lasting impact, because files on disk may be owned by numeric identifiers that remain even if you rename a user later. Thinking in terms of identity records and ownership relationships prepares you to handle account creation and changes with fewer surprises. Adding an account is easiest to do safely when you treat it as a deliberate set of choices rather than a single action called create user. The first choice is the purpose of the account, because a human interactive account should be designed differently than a service account that runs one background process. A human account typically needs a home directory, an interactive shell, and membership in the groups that represent the user's responsibilities. A service account, by contrast, often benefits from a restricted shell or no interactive shell at all, minimal group membership, and a home directory that is either absent or set to a controlled location used only for the service's runtime needs. The second choice is naming and consistency, because clear naming conventions help audits and troubleshooting by making intent visible, while random names hide meaning. The third choice is deciding whether the account should be able to log in at all, which matters for service identities that should exist only as process owners. These choices align with least privilege, because the safest account is the one that starts with only what it needs and then grows deliberately when a genuine requirement appears. Once an account exists, the next lifecycle step is making it usable in a controlled way, and that usually means aligning home directory expectations, default environment, and ownership. A home directory is more than a folder, because many applications assume they can store configuration and state there, and a missing or misowned home directory can create failures that look unrelated, such as settings not saving or shells behaving strangely. If the home directory exists but has incorrect permissions, a user might be unable to create necessary files, or worse, other users might gain visibility into sensitive personal data. Ownership matters here because the directory should normally be owned by the account's UID and by an appropriate group, allowing the user to manage their own environment without needing elevated privilege. For service accounts, The safest approach is often to avoid a general-purpose home directory unless the service truly needs one, because unnecessary writable locations increase the surface for misuse. This part of the life cycle is often tested indirectly, through scenarios where a new account exists but cannot function correctly due to missing expected directories or mismatched ownership. When you think about usability as a set of file system expectations, you can predict and prevent these issues. Shell choice is another lifecycle decision that beginners sometimes treat as a personal preference, but it is also a control surface that affects risk. A shell is the program that interprets commands, launches processes, and defines the interactive experience, which means that granting an interactive shell is effectively granting a powerful interface to the system. For typical users, a standard shell is appropriate because they need a working environment, but for service accounts, an interactive shell can be unnecessary and dangerous because it enables a direct login path that may not be intended. Restricted shells exist as a concept to limit what a user can do interactively, but even without relying on a specific implementation, the security idea is simple. If an account should not be used for interactive work, it should not have an interactive shell that invites such use. Another subtle point is that the shell listed in the account definition must exist and be accessible, or logins can fail or behave unexpectedly. Linux Plus questions sometimes frame this as an account that cannot log in even though the password is correct, and the real issue can be the shell path or shell availability rather than authentication itself. When you treat the shell as part of the account's capability set, you naturally choose it with intent rather than leaving it as an afterthought. Group membership is where account lifecycle management becomes a real access control design task, because groups are how Linux scales permissions without making everything world accessible. A user typically has a primary group and may have supplementary groups, and those groups are what allow access to shared directories, shared applications, and operational tasks without granting full administrative authority. Beginners often respond to access problems by opening permissions broadly, but the safer long-term fix is usually to place the user in the correct group and ensure the resource is group-owned with appropriate group permissions. This is least privilege in action because it grants access specifically to the role group rather than to everyone. Group management is also where role changes are implemented safely, because you can add or remove users from groups as their responsibilities shift without editing thousands of file permissions individually. Linux Plus questions often test whether you understand that being in the correct group can unlock access without changing the file's owner or making it public. When you consistently think in terms of groups as roles, the account lifecycle becomes a straightforward process of aligning identity with responsibility. Modifying an account is the most common lifecycle task in real environments, because people change roles, projects shift, and systems evolve, so static account definitions rarely stay correct forever. Safe modification starts with understanding what kind of change you are making, because changing a username is very different from changing group membership, and changing a shell is different from changing the home directory. A username change can affect scripts, references, and human expectations, but the underlying UID might remain the same, which is why ownership relationships can remain stable even when the name changes. A home directory change can be even more disruptive because it changes where the system expects user configuration and data to exist, and it can break applications that rely on paths inside the home directory. Shell changes can affect both usability and security, especially if a shell is changed to something more permissive or less controlled than intended. Group membership changes can immediately grant or revoke access to shared resources, which makes them powerful and also makes them audit relevant. The key lifecycle habit is to treat modifications as policy changes with consequences, not as cosmetic edits, and to anticipate what dependencies might be affected by each type of modification. Least privilege becomes especially important when you think about administrative access, because this is where beginners are most tempted to solve problems by making accounts overly powerful. Linux distinguishes between normal users and privileged operations, and there are controlled ways to grant administrative capability without turning every user into a full administrator all the time. The concept is that most work should be done as a normal user, and only specific administrative actions should be elevated, ideally with accountability and scope control. If you grant broad administrative group membership as a default, You expand the impact of mistakes and make compromise more damaging because any account takeover becomes a system takeover. A safer design is to grant privileges based on job requirement, keep privileged memberships limited, and periodically review who has elevated access. On the exam, questions may present scenarios where a user can or cannot perform an administrative action, and the intended reasoning is often about whether the account has the right group membership or elevation policy rather than about whether the system is broken. When least privilege is your default, you can explain why a restriction exists and you can choose the minimal change that fixes the problem. Passwords and authentication policies sit alongside account lifecycle because they control how an account is used, not just whether it exists. A new account may need an initial password or an initial authentication method, and modifications may include resets, expiration changes, or lock and unlock actions depending on policy. The key concept is that authentication settings are part of lifecycle control because they can enable or prevent access even when permissions are correct. Beginners sometimes focus only on file permissions and forget that an account can be disabled, locked, or restricted in ways that prevent login entirely, which is often intentional during offboarding or during incident response. Another subtle point is that service accounts often should not rely on human-style password login at all, because automated services can be configured to run without interactive authentication, reducing exposure. Linux Plus questions may describe an account that exists but cannot log in, or an account that is meant to run a service but should not allow interactive sessions, and the right reasoning is to separate identity, authentication, and authorization as different layers. Account lifecycle management is therefore not only about creating records, but about controlling access over time through authentication policy decisions. Deleting an account is the lifecycle step that most clearly demonstrates why planning matters, because the most dangerous part of deletion is not removing the identity record, but dealing with what the identity owned and what depended on that identity. Files on disk do not vanish automatically when an account is removed, and they can remain owned by a numeric UID that no longer maps to a username, which can create orphaned ownership that is confusing to audit and manage. If the account owned important data, you need a plan for transferring ownership or archiving data before deletion. And if the account owned service files or ran scheduled tasks, you need to remove or reassign those responsibilities safely. Beginners sometimes believe that deleting an account is the final cleanup step, but in mature practice, cleanup comes first and deletion comes last, because you want to ensure the system remains consistent and nothing critical is left in a broken state. Linux Plus questions often hint at this through scenarios where an account was removed but files remain, or where a service fails after an account change. And the correct answer involves understanding that identity changes do not automatically rewrite ownership across the file system. Treat deletion as a deprovisioning process rather than a single step, and you avoid these lifecycle pitfalls. Deprovisioning also includes disabling access before removal, because a safe lifecycle often separates stopping access from erasing the account record. When a user leaves an organization or a service identity is being retired, the first priority is usually to ensure that the account can no longer authenticate and can no longer be used to start new sessions. That can be followed by reviewing group memberships, removing elevated access, and confirming that no automated jobs, keys, or scheduled tasks continue to run under that identity. Only after those dependencies are handled should the account record be removed, and any necessary data should be archived or transferred according to policy. This staged approach supports both security and troubleshooting because it preserves the ability to inspect what the account was doing while still reducing risk immediately. It also reduces the chance that you delete an account and then discover you needed information tied to that account's home directory or configuration. Linux Plus questions that involve account removal are often assessing whether you understand this difference between disabling and deleting, because disabling addresses immediate risk while deletion is a long-term cleanup choice. When you carry that staged lifecycle mindset, your answers naturally sound like careful administration rather than like impulsive changes. Service accounts deserve special attention in the lifecycle discussion because they are where least privilege is most visible and most important. A service account exists so a background process can own files and run with a constrained identity, which means the account should have access only to the directories, sockets, or resources the service actually needs. Beginners sometimes run services as overly privileged identities because it makes errors disappear, but that is a dangerous pattern because it gives the service more power than necessary, increasing the harm if it misbehaves or is exploited. A safer pattern is to create a dedicated account, grant it ownership or group access only where required, and ensure it cannot be used as a general login identity. This also makes auditing clearer, because when you see that identity touching files or creating processes, you can attribute it to the service rather than to a human user. Linux Plus questions often use services to test account lifecycle reasoning, such as why a service cannot write a log file, which is typically an ownership or group alignment issue with the service account. When you understand the lifecycle role of service identities, you can solve these scenarios by adjusting access narrowly instead of widening permissions globally. Account lifecycle management also includes periodic review, which is less dramatic than creation or deletion, but just as important for keeping a system secure and predictable. Over time, users accumulate group memberships, old accounts remain enabled longer than intended, and service accounts may remain after services are retired, creating unnecessary access paths. A review mindset means checking which accounts exist, which are active, which have elevated rights, and which belong to sensitive groups that grant broad access. It also means validating that default shells and home directories make sense, and that accounts that should not be interactive are not accidentally configured for login. This is the practical side of least privilege because least privilege is not a one-time setup. It is a state you maintain by removing access that is no longer required. Linux Plus questions sometimes frame this as good practice rather than as a specific fix, asking which action best supports security, and periodic review is often the most defensible answer. When you treat lifecycle as continuous, you naturally keep systems cleaner and reduce surprise behavior during incidents. By the time you reach the end of this lesson, you should be able to tell a clear story about user and service identities that covers creation, modification, and deletion without turning into a checklist of commands. Creating an account means defining a numeric identity, a group context, a home directory expectation, and a shell capability, and those choices should be guided by the account's purpose and by least privilege. Modifying an account means adjusting those properties thoughtfully, recognizing that changes to names, groups, home directories, and shells have different dependency risks and different security consequences. Deleting an account is not simply removing a name, because files, scheduled tasks, and services can remain tied to the old UID. So safe deprovisioning involves disabling access, transferring ownership, and cleaning dependencies before final removal. Shell decisions shape whether an account is interactive or constrained, and group decisions shape collaborative access without opening resources to everyone. If you can reason through these relationships, Linux account questions become straightforward because you're answering from system behavior and security intent, not from memorized steps.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.